Ever found yourself pondering on how the Hadoop distributed file system works? Well, you're in for a treat. The Hadoop Distributed File System, or HDFS, is a unique file system designed for storing and processing big data. It's a crucial part of the Hadoop framework, which many of you might have heard of. The primary purpose of HDFS is to handle large data sets. This isn't your everyday file system that stores documents or pictures. HDFS is built for big data, and by big, we mean really big. Think petabytes and exabytes of data. What sets HDFS apart is its ability to run on commodity hardware. That's right, no need for supercomputers or high-end servers. HDFS can operate on standard, off-the-shelf hardware, making it cost-effective and accessible. So, HDFS is all about big data, affordability, and accessibility. Now that you have a basic understanding of what HDFS is, it's time to delve into how it functions. HDFS is not a standalone entity. It comprises several components that work in unison to make it the robust system it is. At the heart of HDFS, we find three main components: name node, data node, and secondary name node. The name node, acting as the master node, is the brains of the operation. It manages the file system metadata, keeping track of where data is stored, how it's divided, and how it's replicated. Enter the data nodes, the worker bees of our Hadoop hive. These nodes store the actual data, diligently handling read and write requests from the clients. Lastly, we have the secondary name node, not a backup, but more of a housekeeper. It performs periodic checkups and housekeeping tasks, helping the name node to maintain the health of the system. These components collaborate to ensure HDFS operates optimally. But how do they interact? Let's find out next. Now that you're familiar with the components of HDFS, let's explore how they work together. When you interact with HDFS, you're essentially managing data. But how does it happen? Well, it's all about breaking down and spreading out. Imagine you have a large file you want to store in HDFS. What happens first? The file is split into smaller, more manageable pieces, known as blocks. This isn't a random process though. The size of these blocks is predetermined, usually around 128 megabytes, but it can be configured based on your needs. Now, these blocks don't just sit together in one spot. They're distributed across the network, stored on different data nodes. Picture it as a warehouse where each block is a box, and the boxes are spread out on various shelves. It's a clever way to utilize the storage capacity of multiple nodes and to ensure efficient data processing. But how does the system keep track of where each block is stored? That's where the name node comes in. Think of it as the warehouse manager, keeping a record of which block is on which shelf, or rather which data node. It maintains a directory tree of all the files in the file system and tracks where across the cluster each file block is located. Now, what if a data node fails or a block goes missing? HDFS has got that covered too. It automatically replicates each block across multiple data nodes. This replication provides a high degree of fault tolerance. It's like having backup copies of every box in our warehouse analogy. Finally, how do you retrieve your data? A client doesn't need to remember where each block is stored. Instead, it contacts the name node, the warehouse manager, to find out the locations. The client then directly accesses the data nodes to retrieve the data blocks. It's a streamlined process to ensure quick data retrieval. That's a simplified explanation of how HDFS works. It's an intricate system designed to handle big data efficiently. So, we've traversed through the HDFS landscape, understanding its components and their interactions. Let's do a quick recap. We've learned that Hadoop Distributed File System, or HDFS, is a distributed storage system designed to run on commodity hardware. It's a crucial part of the Hadoop framework, allowing for the storage and retrieval of big data. We looked at the main components of HDFS, namely the name node and data nodes. The name node manages the file system metadata, while the data nodes store the actual data. We've also discussed how these components interact, ensuring data is stored and retrieved effectively and efficiently. We've also delved into the workings of HDFS, understanding how data is divided into blocks and distributed across multiple nodes. This ensures fault tolerance and high availability, making HDFS a reliable choice for big data processing. HDFS, with its distributed architecture and fault tolerance, is indeed a cornerstone in big data processing. Next time you're handling big data, you'll know what's happening behind the scenes. Until then, keep exploring and keep learning.